What's up, lads? Back at it again, June 2nd, 4:30 p.m. Um, Tried to do this just now, couldn't do it. 889 construct binary tree from pre-order and post-order traversal. I want to take a break from the lectures. Just don't want to do the lectures, man. So we're gonna switch it up, do some leak code, and then maybe later we get back to the lectures. Um, yeah, I really want to try and trade some shit, maybe. Like that'll be pretty cool. But yeah, anyways. Anyways, let's do it, yeah.
Write some more neat code today. So today let's solve a pretty fun problem. Construct a binary tree from a pre-order.
Fun!
We're
Woo!
actually
Woo!
two inner
Woo!
one
Woo!
traversal
Let's go!
in order traversal of a binary tree. And our goal is to take these two traversals and the orderings of those nodes and then reconstruct basic.
Okay, so pre-order, you go root value, DFS left, DFS right. In order is left, value, right. Okay? We got that.
Binary tree that the traversals are from. And it is technically possible. These two traversals have all the information we need. We just need to take that information and then deconstruct it and then reconstruct this binary tree from those. So just to verify it, let's go through this tree and actually do the pre-order traversal first of all. So first, we know pre-order traversal is you start at the root and then you
3, 9,
then you do the left
20,
subtree,
15,
then you do the
17.
right subtree, right?
29, 20, 15, 17.
Let's just do the pre-order traversal. So we're starting at the root. We do the root numbers first at 9 input. So this is as well. In order traversal is we start
9,
with the root,
3,
right? We take care of the entire left
9,
subtree
3,
roots,
15,
then
27.
take care of the root
9,
node,
3, 15,
and
27.
we take the left values in the exact same
Yep.
order as
Cool.
that in order traversal that we were given. So we can see that that what they gave us was correct, but now the question remains, how can we actually take these two arrays, these two traversals, and construct this tree? Well, it's definitely possible. Let me show you how to do that right now. So I just want to let you know that there's actually two main facts that we're going to be using to construct this tree. So the first fact
is the first element of the pre-order has to be the root, right? It has to be.
is that the first value in pre-order traversal is always going to be the root, right? We remember when we do pre-order traversal, right? We're always processing the root first.
And the first element of in order will be the leftmost, right?
So if I was taking the pre-order traversal that we're given, right? We remember this is the pre-order traversal that we're given. We construct now the left subtree and the right subtree, right? We're done with this three, right? Now our goal is to reconstruct the left subtree. Hey, lucky for us, the first value here is always going to be the root of the left subtree, right?
If there's left subtree, yeah.
Right? because that's how preorder traversal works, right? So that's one thing that we're going to use. The first value is always going to be the root, and then we can take the sublist, right? We can remove the 3. We don't need to look at it anymore. Then we take the sublist, and then basically we're going to do this recursively. That's what I'm telling you. Okay, we can construct the root, but we need more information than that, right? And then let's say we're done looking at this 3 now. I want to take this array, right? And I want to know which values are going to go in the left subtree and which are going to go in the right subtree. From looking at the actual tree itself, we know the answer, right? We know that this is where we're going to cut our list, right? The 9 is going in the left subtree, right? These 3 values are going in the right subtree. But how can we determine that? Well, that's what we need our in-order traversal array for. Okay, so now let's take a look at the input array we're given for the in-order traversal. And by the way, let me just mention that every value in the traversal is guaranteed to be unique. That's true for both of the traversals, the in-order and the pre-order. Every value is going to be unique because every value in the tree is going to be unique. But okay, so far we know that this first value 3 is going to be the root, right? So now let's find 3, right? We know 3 is...
Oh, so anything before the root value for in order will be on the left, right?
the root, right?
And anything on the right of this in order will be on the right.
So we removed it from our first list, basically, right?
Thinking.
But now let's find it in our in order list. We find it's right over here. 3 is in this index, right? So we know we don't need this 3 anymore, right? We already created that node. But so now what does this in order array tell us? Notice how this is convenient for us. Every value to the left of the 3 that we just created the root from, every value over here, which is only 9, is going to go in the left subtree, and every value to the right of 3 is going to go in the right subtree. That's really convenient for us. Why is this the case? Because that's basically the purpose of in-order traversal, right? It guarantees that we're going to go through the tree in order, right? From left to right, basically. Right? So if we see the 3 here, and this is the position in the array, you know everything here is going to be in the left subtree, everything here is going to be in the right subtree. That's what it tells us. This is really convenient for us because we can count it, right? We can see there's exactly 1 value that's going to go in the left subtree, and there's exactly 3 values that are going to go in the right subtree. So what we can do is we can take the remainder of the pre-order array and then partition it, right? Partition it over here because we know 1 value is going to go in the left subtree and 3 values are going to go in the right subtree. So that's what we're doing, and we're going to continue this, right? So now let's and by the way, in the code, we're going to do this recursively. Let's create the left subtree. We know that, okay, this is the in order portion, right? And this is how we're going to partition it from pre-order, right? We see this is the array to create the left subtree. The thing here is, notice how this is size 1, right? There's only 1 value here and there's only 1 value here, right? That tells us that the subtree we're creating is only going to have 1 node in it, right? So 9 is the only node in the left subtree. So we're going to create that node, put the value there, and now we're basically done with this left subtree, obviously, because there's no more there's no more nodes left in this general area, right? These values are reserved for the right subtree. This is reserved for the right subtree. Okay, so now we're looking at the pre-order portion, right? There's 3 values, just like in the in-order portion. And remember, how are we going to create the root node of this subtree? Now, we always take the first value in pre-order traversal. It's 20, right? The value is 20. So we're going to take this value 20. We don't need it anymore because we're going to create a node from that value. And so now we need to know which values are going to go in the left subtree and which are going to go in the right subtree. We know by finding 20, right? 20 is the value. Let's find 20 in our in-order traversal. It's over here. By the way, in the code, I'm going to be calling the index of this mid. So M for mid. We find the index of 20, right? We know we don't need 20 anymore. So we let's just take the length of the left and right subarray. So the right subarray is 3 and the left subarray is 1 node. Now these counts 1 and 3, they tell us how to partition the pre-order traversal. So take a look at the pre-order traversal. 1 tells us that we're going to cut over here because this needs nodes to traverse through the two arrays that were given. That means we can return null, or basically we don't have to create a tree. So if pre-order is empty or in order is empty, then we can return null. We have no values, so we
Okay, fine. Sure, let's get into the code. So if pre-order right,
don't need to create a tree. We can return null.
fine.
Otherwise, we're going to create a tree node, right? And what's the value of that tree node going to be? Well, it's going to be
Okay, so root.
the first value that happens to be in the pre-order array, just like I showed you, right? Always going to be the first value, so it's always going to be index of 0. And then whatever that value was, we want to find the position of it in the in-order array. So in-order dot index, so we want the index of that value, pre-order of 0, and we're going to get it in mid. Now this
Do need this because these are only integers, right? So I'll have to give it a constructor. Um, and then the actual value in mid will be equals to at maybe, right? Insert erase. No, so I should just search for it, right? break the loop, right? Okay, now I found it, and everything on the left would be on the left of the tree, right?
Is the part where we're going to build the subtree. So root dot left, let's create the left subtree, and we're going to do this recursively as I mentioned. So self dot build tree.
That's crazy. How would you even think of that though? The pre-order would be would be the array without the first.
We're calling the function that we're inside of. And the convenient part about Python is we can do sublists, so that's going to cut down our code quite a bit. So we need to pass in the new preorder and inorder array.
That's insane. Does that work? I wonder if this works. Does this syntax work? Oh, cool. And then the new in order would be would then be everything on the left, right? Tonight, behind us. Na, 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 na. Yo, oh, so left and right, this should be the same, right? Reorder should be the same, but in order would be different. Something like that, probably. Fuck. I celebrate my love for you. Mm, 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 Tonight.
Or the mid tells us how many, and we're basically in Python, this mid.
Ah, shoot. To get close to you. Is to get close to you tonight. I celebrate my love for you as we live to tonight. Maybe.
Plus one isn't telling that, but nodding. Basically, we're just creating the appropriate.
Yep.
Sublet. You're not fixing the exact same thing. We want every node to the right of mid in order, right? From our in order array, we want every value to the right of this index mid, starting at mid plus one, and then going until the end of the array. So now let me close this function. And so this is literally all you have to do. The reason it's so easy is mainly because I'm using Python, but you could do this code without Python. It would probably just be a couple extra lines. You might need to pass in a couple extra parameters into this build tree function, basically just these indices that I'm doing. You might not be able to create sublet. Tree, tricky, soup.
Why? Why, bro? What's wrong with this code though? Mm, 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 mm. Literally what I did. Mm, 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 mm. Tonight I celebrate my love for you. It's tonight. Na, 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 da, na, 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 na. Gonna get close to you tonight. I celebrate my love for you. It's easy. Da, 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 da. Na, na, tonight. Boom, boom, da, 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 da. Na, 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 na. Na, 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 na. Don't really know what's wrong, fam. Ugh. When I wake up to you is to get close to you. to get close to you tonight. I celebrate my love to you. Oh my God, I'm a dumbass. That's why. Am I a fucking dumbass? Okay. Bruh. Fuck. Okay. Bruh. Bruh. Tonight I celebrate. I am a fucking dumbass. Yep, so I did as well. Tonight I celebrate my love for you. It seems you feel it too. Tonight, in order index. What is this limit? If pre-index is bigger or equals to else if and root values and limit. So after this, pre-index should become one, right? If I'm not mistaken. And if I ask root value to become the limit, is to get close to you. Tonight, we celebrate my love for you. It's easy. Na, 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 feel it led to tonight. We're both be blinded. Mm, 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 mm. It's to get close to you. I don't really understand what these two ifs are doing. Like this, I get it. This, I don't really understand how they're using two if loops to slice the vector, right? Because that's the main part that is giving me a lot of memory uh like usage, which is bad, right? So if I can, I'll definitely want to reduce it. Um Yeah, I mean, my version was very unoptimized, but this one is way too optimized. I don't even know what they're talking about. Straight up. Give me the loot. 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 See. Yeah, yeah, yeah. I mean, the if. Da-na-na-na-na-na-na. Na 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 na. Na 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 na. So it's one pass, right? Because pre-index will only increase. Okay. So pre-index starts at 0, and then I'll create uh one root, and I'll call this. Right now pre-index is 1. And then I will call the same thing, and then the limit will be root value. Ah, I see, I see, I see. So if I finish from the left side, wow, this is so smart. How would you come up with this though? How do you ever come up with this? Na 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 na. It's to get close to you tonight. I celebrate my love for you. It seems. This is the part I don't get. Is left of Like that's so smart. If pre-order is bigger, that means it's at the end, right? But if in order is equals to limit, now plus. Like that's crazy though. Like that's actually crazy though. How do you even think of that? I have no words. I am actually speechless. Right. This returns free node. Right. This is insane. This is actually insane. Left limit height. This, right? Whatever the limit is. See, this is fucking crazy as well. Like how do you come up with the concept of limit though? like this is so unrealistic to 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 come up with. Like even if I have the answer, it doesn't make a lot of sense, you know? Like that's completely fucked. Something to do with this has to be. Speechless. I'm speechless. Absolutely unrealistic. Absolutely unrealistic. This one is the one that I've seen. That would probably be the craziest. Like I read this and I'm like, what the f how do you even think of this though? Okay, whatever. Um, I'm gonna call it there. Like this one, understandable. This one actually understandable, right? But the other, come on, bruh. Like, okay, first, seeing the fact that you have to use recursion for this is already insane. On top of that, you have to do it the optimized way using the pre-index, the in-order index. Like, that's fucking nuts, dude. Anyways, see ya.